networks. So what is a neural network? So it's basically, at a high level, it's a computer model that is loosely modeled after the human brain. So there are three layers. As you can see, there's the input layer, the hidden layer, and the output layer. The input layer is connected to the hidden layer through weighted connections right? And so the hidden layer is connected is composed of two parts, the synapse and the neuron. The synapse is the weighted connection, which is modified according to patterns in the input data. The neuron is slightly more complicated. It can be connected, multiple synapses can be connected to one neuron, and an activation function is applied. And an activation function is applied to the sum of all the weighted connections. So first, after all the calculations, the output will be pretty inaccurate, right? But according from patterns from the input data, it makes an accurate output, right? So how it makes an accurate output? Because first you're given some input and then it creates some random output. So you need to get accurate. So that's the purpose of a neural network. So what it uses is a method called backward propagation. So it consists of three steps: forward propagation, and error estimation, and backward propagation. So what it does is tries to minimize the error in the cost function so that it's as close to the desired output. So let's say you want to input an image of a dog and want to see if it's a cat. If you want to see if it's a cat or dog so first it will be wrong. So it looks for input. It looks for patterns in dogs, what kind of the dogs they are, what legs, etc. And then the weighted connections are modified, and the activation functions are modified, and you get an accurate output after thousands of tries. So that's just a high level of a basic neural network. There are various neural networks, but there are two main kinds. The supervised ones and unsupervised ones. The ones that use supervised learning, they are the simpler ones, and they're used extensively in pattern recognition and voice recognition. So much more complicated ones are the unsupervised learnings. So they don't have any desired output. So they're much more open-ended, and the result is rather unpredictable. An example of an unsupervised neural network is the deep convolutional network. So how it works is that it also uses backward propagation. Instead, it uses a special method called autoencoding. So the input is directly connected to the output in a complex fashion, and it's done that way, since you don't know what the output is supposed to be. And it also uses organizing clusters called maps, because you don't know what the output is supposed to be. So I just told you everything about neural networks, and you might be thinking, who cares? So let's just get a quick comparison of neural networks versus kind of conventional computing. So for neural networks, let's look at the processor. Normally, you have a complex central processor. Instead, in neural networks, you have neurons and synapses. And usually you have to explicitly program a neural network. Instead, in a neural network, it varies based on patterns in the input data. And another big one that people often don't consider is data management. And usually you need allocate specific memories for storing data before you do some processes. Instead, the data stored in the neuron's activation state. So who cares about these benefits, you might ask? So first, this makes it much more adaptable depending on the type of input you're giving. The second is that you have more efficient pattern recognition compared. And then the second one is it's useful with vague relationships, which are really hard to code normally. And it's very effective with high data diversity when you're given tons and tons of variables. So let's talk about applications. There's a big application in the medical field, and currently in today's world it's mainly used for modeling specific parts of the body and diagnosing diseases. So I'll be specifically going to the cardiovascular system. So an example of how it can be used is that you can have an ideal model of the cardiovascular system and then the patient's model, right? So and then the ideal model will have what the ideal heart rate, physical activity, etc. is supposed to be. But this is all variable considering the actual individual, right? So the neural network must adapt based on the individual. Normally this would be very hard to code, but neural networks make this very easy. So you can compare and you can use this to diagnose various diseases in the person if you see an abnormality. And another thing is that various factors are involved, and that also makes it useful for neural networks. And it's also obviously useful in business because you can also use it for marketing, stock prediction, and credit evaluation. So those are all their other applications. So now let's look and talk about how it can affect your life. A big thing is image recognition. Normally this has been a very rather hard thing for computers to do. But with neural networks in the past 3 years, it is that computers have actually matched or exceeded humans in very hard visual tasks. An example of a company that's been working hard at this task is Google. So another application is natural language processing. So usually, like when we translate, human translation and computer translation is different. So human translation, computer translation is different. And this because it's very hard to encode sentiments, context, etc. For example, the fly in the sentence, it could be flying or it could be that fly itself, right? So neural networks can look at patterns from billions of different sentences, paragraphs, essays, etc. And they can create meaningful patterns. And we have actually seen huge progress in the past 3 years, and we're moving much closer to having natural conversations with the computer. So what I want us to say is that neural networks are actually a rather concept that has been around for a long time, so like since the 1980s. But in the past 3 years, companies like Google, Amazon, Netflix have seen huge progress, and it's because of the vast computational power we have today. So I really do think that it has a bright future, and the next steps for me are to use things like TensorFlow and scikit-learn to get more in-depth into neural networks and actually create neural networks. Thank you.